Hey, how we doing, everybody? Couple minutes late. Well, I don't know where that time went. Not to worry, I'm here. Don't worry, I'm here. Sean wants to start without me, and Sean, thanks for the super chat, mate. Straight in, no messing. I think it was. I'm trying to think who was in first. It wasn't Floppy Fred, but Floppy Fred's at the top. So how are you, Floppy? You got to pop out like Mary Poppins, and hopefully you're going to be back in time. Fingers crossed. I think it was Michael in first today. Daniel, hi Daniel. Sean, the man cave. How you doing, mate? Phil Taylor, how you doing, Phil? How many minutes? You're having bets on the side, Sean, as to how many minutes late I'm going to be. I made it 2 minutes late, mate. 2 minutes. The new capacitor bingo, 3 minutes late. Hi, Nick. Hi, Daniel. Hi, Aston. Benji's in. Hi, Benji. Andy Tobin. Hi, Andy. Just trying to catch up with the comments. Christ, there's loads of you in already today. David Tag. Hi, David. How are you? Can't see Nick. I don't know why I can't see you, Nick. Whether he's having a wind up, I don't know, mate. I can see you, Nick. Anthony Carr, how are you? Aston's been on the Irish coffee. Very nice. I made one of those for a while, Aston, actually. I normally have a bit of a dabble with that at Christmas, but it's not usually Irish. What's the Scotch coffee called? I can't remember now. Afternoon, Colin. Just making sure I've got everybody. Rob Titheridge. Oh my God, it's just jumped again. Hi, Rob. Doug's in. Doug, I can't find your adapter. Can't for the life of me find that valve adapter. Can't for the life of me find that. I do not know where I've put that. I put it somewhere really safe, Doug. Hi, Brett. Hi, Simon. Simon's World. Hi, Rob. Rob Cross. Yeah. So, there we go. Yeah, today's stream. I did a bit of studying on Monday, really, after Sunday's stream, just to get my head around the schematic a little bit better, just to make sure I've wired it all up properly, which I have. Afternoon, Gavin. Afternoon, Richard Milliken from Welsh, North Wales. So, yeah, I actually found a break in the medium wave frame antenna, and I have tried it this morning. It is receiving a bit better now. It's not brilliant still, and we've still got issues with voltages. But one silly thing that I didn't try, well, we ran out of time really. I went way over time last Sunday really. I try and keep it to 4 hours, but I think I went up near 6, and maybe more than 6. Now, just below 6 hours last week. But one thing I didn't try, and it was pretty obvious really, was the battery supply, because I've got a battery eliminator here that'll do the 90 volts and the 1.5 volts. Of course, that actually bypasses the rectifier. So I think someone either sent me an email or put it in the comments. So whoever that was, I thank you very much. And yeah, very good idea. Also, I had some info through from a chap up here called Richard, who I've done some work for in the past. He sent me a copy of the schematic with some voltages on. So we've got that to look at as well. So hopefully today we can get to the bottom of this, and I think we're going to end up having to change out the rectifier, so at least the HT one for sure. But what's confusing me is these measurements. Now I spoke to Les in the week, and he was saying across the HT I should be getting about 50 odd volts. Well, I couldn't work that out, because as far as I'm concerned, in my head it needs to be 90, but apparently it depends where you test it between. So again, anybody can help with that. As I say, I'm not a Valve man. I don't really know what I'm doing, but there you go. And Derek, afternoon Derek, and Rob Cross. Thanks for your help. Thanks for the super chat, Rob. Very disappointing you don't like switching off. Oh yeah, Ulster. I think it's Ulster radio, is it, has gone off air, Rob? On, was it long wave or medium wave? Yeah, so unfortunately yet another AM station shut down, which is a shame, a real shame. I don't think I can get Ulster, I can get RTE. Hi Paul, Mr. Cody's, check the pin sockets on V3. Loose one will cause you problems. Cheers Paul. Check the pin sockets on V3. As I say, it is working a little bit better. I did find a break in the frame area. I did have to do a picture of that somewhere here. I did do a picture of that. Let's have a quick look. It's probably when I was manhandling the thing, I would think. I suspect it's me that broke that, but you know how it is. As I say, I know not what I'm doing. So where are we? Screen capture cube. There we go. So that's that wire was poking through the hole, but it wasn't connected to anything. And I read a little article. Someone had a similar problem to that, so I thought I'll just give them all a little tug. And sure enough, that one wasn't actually connected to anything. So what I've done, I've cut it back, and I've put a bit of enamelled copper wire, soldered that on, and poked it through and wrapped it around the terminal. So that is done. That is done. Now I need to find the schematics again. I think I downloaded them. I hope I did. I've just opened that about 3 times again. I keep forgetting that it goes a bit slower. RMB. Did I download the one that Richard gave me? Let me just see if I can find this one that Richard sent over. Thank you, Richard, if you are watching, for sending that over. I think Richard's had one of these before and worked on it. But certainly I think checking it on the battery supply is gonna show that we've got the correct voltages everywhere. And what I'll do is I'll go over some of the valve bases. I haven't had time. I was going to work out the pinouts for them. Now let me think. Where did Richard send it to me? Sent it on my email. So bear with me. I'll just find this. Oh, it wants to review my account details. Oh, okay, that's all right. No, that's fine. Whew. Computer's on a go slow again. Benji's birthday. Oh, I've got to get me Gus Honeybun badge on then, Benji, for you. And Sean had a birthday in the week as well. Mr. Man Cave. Let's get me Gus Honeybun birthday badge on and we can wish. Because Mr. Spanky said I had to wear it for birthdays. So happy birthday, Sean, and happy birthday, Benji. Mike Atlantis, how you doing, mate? Right, let's see if I can find Richard's email there a minute. Here we go. Let's download this. Oh, this is the problem, I haven't downloaded it. Okay. So this is what Richard sent me through. It's basically a trader sheet, which is a good good circuit, and he's got some voltages on here. So we've got basically looks like about 85 volts on the anodes of V. I think that's right. Anodes of V1 and V2. 81 volts on V4. 11 volts on V3. The HT, I'm sure, should be a lot higher than I've got it anyway. Thought there was some volve data on this. Might be a bit further down, maybe. Yeah, here we go. So yeah, this is the voltages, and we've got nothing like this. I've got to familiarise myself with the actual chassis to see which valve is which. It's all right for you guys that know these things, but I got to try and stumble through it. Have I got a layout on here? We got a layout? Yeah, there we are. Okay, so it's V1 is there. V4 is up the top. Okay. But again, the problem I got is I don't know what pin is what on here. Yeah, so these were measured on the 400 volt range of a Model 7 avometer, chassis being the negative connection. So I'm only getting sort of around 50 volts for these higher ones. For some reason. So I'm not sure why. Is there a... Yeah, so what I ought to do really is do a little plan of the valve bases to show what they are. So we've got a little picture here of all the valves, and this is... Just trying to see there. So that's the... valve base, I take it, the heater, It's grid, that's the anode there, so that's on pin 2 of V1, so I can see V4 easy enough. So it looks like that's on the second pin. And the heater on V4 is linked, that's why I couldn't get the voltage on the heater on V4. I don't know exactly how that works, but it's a mystery, black magic. Okay, so let me just get back to my screen. Let's just alter the camera and we'll get back onto the radio. So at the back here I've got my battery eliminator, but what we'll do is we'll fire it up first, taking care not to touch anything live. So I've still got the lamp limiter in the background, as you can see. Still got the old lamp limiter. So flick that on, it's in lamp mode. Turn it on, maximum volume. And let's wind her up. Let's say we shouldn't have any lighting happening. And I think what I'll do in a minute is I'll take the lamp limiter off the bench, because once you've flicked it into bypass, there's no need to keep it on. I've put a plug on it as well this morning. So it's now got its very own plug. So there we go, there's our buzzy noise. So according to the Variac, it's drawing 20 milliamps. Let's leave it at 240 volts. So medium wave. So it's much better now we've got a medium wave aerial, but it's very hot down this end. Okay. Let's just turn it down a bit. So I'm going to stick the multimeter hopefully in shot. Yeah, you can see that. Let's just pop the camera down a little bit now that we can see that there's no light issues. I'm going to stick the radio on bypass. Shouldn't really do that on and off quick. Right, okay. So let's check these voltages then. So I'm looking at V4 here at the moment, which is the output one on the top here. Let's be careful with this. Let's get can I get that in the shot as well? Sort of. What's in front of that now? That's the lead, isn't it? Okay, so looking at that sheet. Mac Vision, how are you? Phil Tube, hi Phil. I've got Gus Honeybun on. No, it's the rectifier, Sean, almost certainly. Right, let me just get back to my circuit here. So V4, according to that, that's there. Let's heater. So the second pin in, which is that one. So that should be 85 volts, and it's 51, look. So That's the issue we've got. So I'll also check over on the HT over here on the capacitors. So we've got 61 volts on the HT there. Let's check on the HT here before that resistor, 61 volts. So that, I'm sure, should be near 90. And we should certainly have 85 volts on that, and we've only got 51. Now the heaters, just careful that I'm not going to touch anything here. I've only got 1.2 volts on the heaters as well, so the voltage is down on that. So my plan now is to pop that off the mains, and it's actually surprising how long these hold their charge for, because there's no bleed off resistors or anything. So we've still got 37 volts on that. Nothing on the LT side. So, I mean, it could be a resistor issue. I know I've tested the resistor on the HT down here, which is R14, should be 1.8K, it's reading 1.3, 1.4K. And someone also sent me a message saying that if I put a resistor in, I shouldn't replace R14 with a different value, because that won't stop the inrush current apparently from the diode. So if I go over to the screen again, we'll use this. Let's just zoom that in a little bit. So yeah, here MR1 is our rectifier, and R14 is part of this filter network. I think it's a hum filter, something like that. It should take out the hum. I'm not 100% sure, but you know, I think this is the issue where we're getting the hum as well. So someone's saying don't change this one for a different value. Although I have read someone's changed that for 3.3K, and this one for a diode, and that's sorted it. But you know, the person that sent me the message said I need to put one in before the filter network. So in between the diode and this connection here, I need to put in another resistor and leave this one in place. But what I think I will do is change that one for the correct value, 1.8, because for some reason the other one's gone low. I don't know why. I don't think that's going to make any difference, because I've only got 61 volts on the input. So, you know, I've only got 61 volts on the secondary of the transformer. So that's the plan, is to get connected up with the battery supply. So say I've got the isolation transformer plugged in, everything's plugged in to that. This is going to be plugged directly into the mains. So this is my little battery eliminator. Let's go back to the main camera. Center diode. Yeah, I'm the king of dumb questions. So this is my battery eliminator. This is one of these ones that you can buy online. These are particularly good. A little bit bulky, but I've marked HT and LT, so I need to just check inside first to see see what connections I've got, because there's different voltages inside this, and I had it wired up for something different. So just going to pop the cover off of this. Just have a look, see what I've got it wired for. Because we want 90 volts or thereabouts on the HT and 1.5 on the LT. Okay, yeah, well where are we? HT. Yeah, I'm in 67 volts on the HT, so I need to bump that up to the 90. Let me see if I can get you in a bit closer with the overhead camera, maybe. So you can see what the hell I'm up to. Right, so yeah, these are the terminals, and you can see that I don't know if you can see or not, but there's different voltages in there. So I need to be in this 90 volt terminal. As I say, at the moment I'm in 60 something volts. So let's just pop that one out of there. Yeah, 67 volts at the moment. Alright, where's the forceps gone, Graham? I had them here just now, but they've now disappeared. Brilliant. So yeah, I just want to get that out and put it into the 90 volt hole. I have done a lot of battery valve radios, haven't I, really? I've got a lot of battery valve radios, so I should be pretty au fait with them, really, but I'm not. Okay, and the LT is 1.4 volts there. You can't really see that. So I'm going to put that back together. So as I say, going in on the battery supply, we're DC already, so we don't need the rectifier. So this will pretty much prove if the rectifiers are causing the problem. Well, it could be the transformer, I suppose. Could be a dodgy transformer that's got the voltages lower than they should. I don't know, normally they just fail, don't they? Okay, so I've got marked HT and LT, and I've got some chocolate blocks on the connectors here. So I just need to look at the manual now, find out which is which, and connect that up. So let's have a look at the manual. It does say on here somewhere, I'm sure I've seen it, what colours what. Okay. Yeah, that's clear as mud, that is. It says that they're The leads to the tags are A, B, C and D are color coded yellow, green, black and red. Yeah. Doesn't tell you. It doesn't tell you, that's great. So the HT positive comes off the mains battery. Switch. So okay, that's clear enough. That's basically red and black. Can't go wrong there, really. The problem is the LT. Let's just double check this a minute while I'm here. Let's double check this. So that should be the chassis. Let's open. Actually, let's put it in battery. Try that again. Excuse me. Nothing. 300 odd ohms. I suppose it's going through the filaments, isn't it? Who knows? So I'm just going to connect this up. It's quite useful to have this, really. For sets that don't have mains and a battery only. Like that one that Mr. Cody's gave me. Right, that's the HT. So LT. I think that's off the switch as well. Battery. B. Yeah, it doesn't actually say, unless I'm missing it here somewhere. Well, no, the thicker one in the case of the LT unit being the positive, so the thicker one is the positive. So the thicker one is the positive. Okay, I know where I am now. So that's the positive there. Let's connect that in. Unfortunately, I've only got a three-way chocolate block, so this last one's going to have to be. I might just have to tack that on with a bit of solder because I don't really want that dropping off part way round, because we'll lose the heater voltage, which will do all sorts of nasty things, I'm sure. Let's clean that up a little bit. Let's put a blob of solder on there. There we go. hopefully you could see that. No, you can't see that. I'm out of shot, aren't I? Apologies. There. So we are now connected up to our battery supply. Now this will be interesting now. Let's see what voltages we get. Or if it's a big flash and a bang and it goes up in smoke. Smoking. Right. So let's get the lamp limiter out of the way now, because we can run it directly on the mains through the variac. Right, apologies about that, my microphone fell out my pocket. You just bought a woe and flutter meter. I wanted one of those, Simon. I'm going to send you my tape decks now, Simon, to woe and flutter me right up. Okay. So let's turn it off to start with. Let's plug this in. Let's just check the voltages. Make sure we're on the right way round. Okay, nothing on that one, allegedly. 1.4 on there. Why have we got no HT then, Graham? Why have we no HT? I've got it there, but oh, come on. And we got it there. Why haven't we got it there then? Or have we? Strange. Looks like I might have to desolder those leads. Don't think we've got very good contact going on there. We have. Might just be a crusty old That's a bit bizarre. Just check continuity of that a minute. Apologies, I'm not looking at the screen at the moment, people, so if I miss your messages, I'll catch them up in a minute. Yeah, that's got continuity. Just going to write on this. Got myself some new pens. Ooh. George, how you doing? Let's desolder these a minute. Come on. So that one. There we go. Let's put that out of the harm's way. Let's connect these leads directly in. It might just be this crusty old terminal block I got here. It ain't the best. Well, let's try that again. Make sure I'm definitely in the right way around. Yes. There we go. 95 volts. So, fire in the hole. Definitely in the battery. Okay, not a dicky bird. Why is that? Well, we got 96 volts there. Let's check the LT. Okay, so we've got no... there we have. Still got a lot of hum. Well, we've definitely got our volume. We've got this low-level hum though. I wonder if my my caps are okay. We've still got 13 volts on them. I suppose they're still discharging from being used on the mains. We're not going through any of those caps now, are we? I don't think. We're directly off the power supply. So let's have a look at our voltage then. So we've definitely got oh, hang on. It's dropped to 80 volts now. Let's check this one, which I think is there. 83. And so that one, where's that one to? Well, nothing connected to there. I think this one's the one that should be 11 volts. Is it that one? 21 volts, so the voltage is a bit high on that one.
You're definitely ready to give it another go. It's a glow up.
I want to see creativity. I want to see art.
Eating with my ex.
This is maybe going on holiday together, a nice getaway.
Because this is my house.
Hello everyone, welcome.
Wow, that proves that the rectifiers had it on the HT. What do you think? What's the verdict, people? If you have hum, that rectifier is possibly about to go bang. The rectifier's out of circuit, Simon. We're on the battery supply, mate. We're on the battery. Yeah, we're on the battery now, Simon. I've got battery eliminator inlet, so we're not connected up to the mains. Don't worry me like that. Okay, try shorting the wiper to earth. Hang on, let me just Yeah, so the rectifier is out of circuit when the battery is in. I'm sure it is. Try shorting the wiper to earth. You saw the whoa and flutter meter and thought, whoa, you must have a flutter. Short the wiper to ground. See if there's any voltage on that wiper. No, there's no DC on it. So Paul is saying short the wiper to ground, so we can do that. No, hum's still there, Paul. Now you can hear the hum. It's still there with the signal gone to ground. So the hum is still there. You knew that, Simon, did you? You're just trying to confuse me. Yeah, they're out of circuit, aren't they? Hum is from a dodgy supply, you think, George, do you? So you think my battery eliminator's dodgy? It's been perfect for everything else I've used it for, but it could be dodgy. Could be. I don't know. Power supply. Okay, so I think the plan then now, the next step is going to be to get rid of this rectifier. Well, not get rid of it. We'll leave it in. Now, I did see an article in the what am I doing here? Yeah, that's better. I did see an article in on the Vintage Radio forum that Richard, how are you? Let me see if I can find this again. Let's have a look. So let's get rid of me. Let's go to the screen and cube this in. Have a look at this. So this is on the recent repairs. I don't know when it was. It's quite a while ago now. But this guy's saying LT voltage was okay, HT was only around 40 volts. Let me just zoom in a little bit on that. So yeah, this paragraph here, make sure you are you are with me. Yes, we are. Okay. LT voltage was okay, but HT only around 40 volts. He's surprised it worked as well it did with a supply that low, and again, ours is working. So we used a 1N4006 diode in parallel with the old metal rectifier. So yeah, he's connected this diode in parallel to the rectifier. Surely that's not some... I mean, again, this might be fine. It might be fine to do that. I mean, I can easily parallel a diode across there, no problem at all. But yeah, what's your thoughts on that? You gotta think about that while I crack open a beer. I'm going to jail. I can have some jail ale. So I mean, I have got spare valves from other sets that I can play with. But yeah, that's what Richard sent me as well. So I'm going to just get a JLL underway. I had a bit of an overindulgence last night. Myself and Mrs. Cruncher had a bit of a session last night. Listened to a bit of music and had a few drinks. And I'm suffering this morning, so this is the first one, hair of the dog. So George is saying to add a pi filter. We're not going to worry about that because it's not going to be used with a battery supply really. I must get round to putting together a 90-volt battery pack. I've got one to copy there. Cheers everybody. Les. Hi Harvey. Hi Les. But, somebody said to me that I can't remember whether someone emailed me or whether they put it in the comments, but apparently it's better to put the another resistor in the supply to the filter network because it will stop inrush current, and I suppose could inrush current damage the capacitors? Is that what the chap was meaning? So this is the 1.8K resistor that they mention, R14. And he's saying he changed it to 3.3 and it gave an HT of around 87 volts. So what I could do is just get off. Just block notifications, that's the best bet. I could just stick one in with a 1N4007 here with another resistor in that line, and leave this 1.8K in. Well, I'm going to change that for a modern 1.8K because this one's reading low. So yeah, apparently if I just change this one and put a normal rectifier diode there, I'll get too much inrush current going through this this first capacitor. What's your views on that? Doug's saying get the old rectifier out of circuit completely. Leaky rectifier will cause hammer, could short at any time. Reason you can get away with a parallel diode is that the metal rectifiers go high resistance. Ah, right, okay, Rob. So it's better to just, I mean, I've got a tag strip there already that I can play with. He said it was a rectifier all along. It's got to be the rectifier, isn't it? Unless we've got a problem with the transformer. Right, okay, we're all disconnected. Let's get this battery supply out of the way. I mean, that's pretty much proved that the rectifier is no good because of the fact that we've now got the correct voltage at the valves. Valves with an O, obviously. Right, let's go back to the main camera then. Yeah, I'm going to chuck a 1N4007. What are you saying? You can see the chat, best shut it. Right, 1N4007 we need to find. Let's have a look at the old rectifier circuit then. Down here. Down there. There he is. That's the HT rectifier here. Looks just like a load of metal discs bolted together, doesn't it? Probably got some deadly chemical inside it, I suspect, or something like that. Right. I've got to get my head around this as well. It's a bit awkward because this, I really need it sort of stood up that way, but I don't really... Can I get away with that? Yeah, might be alright. I can see it a bit better then. You can't, but I can. Okay, there's our two rectifiers. That's the LT rectifier. That's the HT rectifier. So that is our positive up to the first filter cap. So they still need to be connected. That wire there is the other filter cap, I believe. Yeah. So that is across our capacitors. So that needs to stay in. Selenium. So the wire coming out of our transformer is this one. It's a shame they pulled all these other terminals out, isn't it? So all they've done is they've just tagged a diode across here and changed this one out for a bigger value, which would be dead easy actually. It would save me a lot of headache, but trying to think how the hell I'm going to do this. I've got one tag there, so I could join that, stick it onto there, join from there back to there, and keep this one in just to use that lug, couldn't I? Let's do some things rather than just look at it, shall we? I don't know where my there they are. They're side on. That's why I couldn't find them. Be careful. I don't want to pull the connection there. And this cloth covered insulation is probably not a lot of cop now. So what I'll do is I'll just join that up to this tag, which is spare, and then come back from there and attach it to there. So I'm using that lug. That won't hurt, will it? That ain't gonna hurt, is it? One and 4 are about 1 amp, but the reverse voltage tolerance is the last number. 1N5400 has a larger current ability. Right, let me just show you what diodes I've got then, and you can tell me if any of these are any good. So I've got a 1N5407, which is a monster. I've got a 1N5406, a 1N5400, and a 1N5401. I don't know where we are. Yeah, okay. So I can either fit one of those or a 1N4007. Bob, how you doing? Yes, it is the same radio there, Bob. Just I'm in a bit close. One N4007, so forget these then, yeah? And stick a 4007 in. You're going to make me hunt for a 4007 now, aren't you? You swines. No, I'm pretty sure I know where they are. He says. 1N4007s. God, it's horrible weather here. I don't know what you guys have got there, but so 1N4007s live in box 1. And we've got a shed load of them. Here he is. A bit smaller than those other ones, isn't it? Okay, let me just stick that back and I'll catch up with this chat because there's stuff going on that I don't know about here. What's going on? Let me have a look. I'm back with you. So everyone's saying 1N4007 is fine. That RM0 is 30 milliamps at 125 volts. So you don't need a huge silicone diode. Okay, Andrew, got you. You mean RMB, don't you? That's what confused me. I was trying to work out. Trying to work out what you meant there. So I don't need a huge silicone diode. Let's go 1N4007. So what I'm going to do, I'm going to join this one to that spare terminal. I'm going to... should I just change this one? I don't know that I've got a 3.3K. In a high wattage. What sort of a wattage transistor? Where's the goats? What's going on? Yes, so I should think. He's keeping guard now because he knows I'm going to make another cock up in a minute. Oh, you meant RM0, the selenium rectifier. Okay. Yes, I'm with you, Andrew. I'm with you. I'm with you, mate. Okay. So basically that's got to join onto there. I might actually be able to get away with just that, actually, if I sleeve it all. Yeah, that's best. So I need to put it with the little line facing the direction of flow. Now I could use, I've got some braided stuff here somewhere that I bought. Where's that? Would that go over it? I should have bought the thicker stuff of this. I don't think that'll go over it, actually. It would look nicer. Yeah, I've got some of this stuff, which is, it's braided insulation, so it looks the part a bit more. I don't think it'll go over that wire, though. No, too small. I know Rob did give me some as well. Mr. Rob Titheridge gave me some black stuff, but no, it needs to be bigger than that still. I'm running out of insulation ideas here. I need some thicker sleeving. Oh, hello. It's Mrs. Cruncher's nail varnish gone for Burton. The same size. I do need to get myself sorted with some more shrink of the heating type. Okay, this has gone from one extreme to the other now. This is too big. Way too big. There's a little bit there. Sorry, I'm messing about here. I've got to try and get this right because I don't want to. I'll tell you what I did find as well when I was doing a bit of tidy up yesterday, Andrew, was those quick hats you made me. I actually found them. I actually found them, look. So they're back in the house. Harvey, how you doing? Jess, how you doing? Raining there as well? It's raining every blimmer where, isn't it, at the moment? Right. How are you going to do this then, Graham? You haven't really planned this very well, have you? As per usual. Need a bigger bit of heat shrink than that. Oh, we need heat shrink, people. We need heat shrink. I swear I had some bigger stuff somewhere. What's that there? Is that the bigger stuff or the smaller stuff? And that's that. That's exactly the same. Whoa! Christ. That won't go back in for some reason. I know you pulled my shelves down then. Okay, come on, Graham. Sort yourself out here. Oh, it's up in the archives. I have a piece. Well, that took a bit of finding, didn't it? I had to go deep for that. But I got some. Excellent. What are you trying to achieve here, Graham? Am I cracking up? So if I put that out to there. So I've got to come from there back to there, so I could just go straight to there, couldn't I? Unless I put a resistor between those two and leave this one as is. I'm definitely doing this the hard way, aren't I? So I could have just gone straight to that terminal there with the diode, couldn't I? Save messing about with all of this. You fool. Right, we need to find another resistor. Now, let me think. I'm going to have to dig deep for one of these. There's my little box of resistors. Ah. Right, resistor edge. DAC 90A, so I'm not going to use that one. 5 ohm. $2.2K. Mega ohms. These are ancient, some of these. 10 watts, 15K. $12K. $22. God knows. $15 ohms, 100 ohms, 27 ohms. They're just way too big for that one. Yeah, no. It's the one I took out of Gary's amp. 220. 6.8, 47, 100K, $560, 2.2K again. Yes, my resistor bin. You need a slap with a wet fish. Do I, Harvey? Why's that? I got lots of these 2.2Ks. Very nice. $130 ohm, 1.8K. Come on, give me a 3.3K. 3.9. Yeah, I definitely made that a lot harder than I needed to, didn't I? I could have just gone straight to there with that, because I'm going to use this anyway as my connection point. I don't need to run from there to there unless I was going to put another resistor in series with this one. What have I got over here? I've got some 1.5Ks. $1.5 and a 1.8. So I've got some 1.5 K. Just thinking if I put one of those in, 1.5 and a 1.8, it's 3.3 K, isn't it? Is it resistors in series add together? It is, isn't it? Trying to see what that sits against. That sits against the back of the case. Right, well I haven't got a 3.3K unless it's one of these. Let's catch up with what you're saying. You've got your keys. So that's my plan. A 1.5K in series with a 1.8. And I need to get another 1.8 because that one is way out. You wait, I'll find a 3.3 here, won't I? In the higher value? No, I haven't got a 3.3. I have somewhere got a 1.8 though. In the 2 watt. It's strange, isn't it? That both of those are 2 watt. One's an old one and one's a new one. Crazy. Oh, hang on, they're 1.8 ohms, you fool. Not 1.8K. Oh, bumhole. Maybe I haven't got a 1.8K then. Hundred ohms. Ohms. So I've got some higher wattage ones, but not in the sizes I need. So I've got 4.7K. That's too high a resistance. What's that? 82K. No, none of those are any good. it doesn't look like I'm going to have to stick with my 1.8K, aren't I? I'm going to have to keep this one. I mean, it's low, so I'm not going to get the right output. So I'm going to use this tag strip here and get you back up where I am again. So I've got a spare terminal on this tag strip, so I'm going to go in with my new rectifier diode into there. And whether to go around the outside with this one. Maybe, and on the inside with the new resistor. On the outside with the new resistor. Yeah, I think as I was, I'm going to go on the inside with that. Right, let's get burning. Let's get melting. Stick a bit of flux on there because this one's never been used before. I suppose I ought to put a bit of insulation on that, prove willing. Cock of that rain, it's absolutely hammering it down now. Come on, there must be a hole there somewhere you can go through. Eh? There must be. It's a beauty, isn't it? It says it's only 2 watts. Yeah, 2 watt high stability carbon film, 1.5K. It's massive, isn't it? High stability though, not high fidelity. We've obviously got a hole here for that to go through, so why can't I fit another wire through it? There we go. There we are. Okay, so I can cut that off a little bit, which is good because I've just squashed it. Right, so the combined resistance of those is going to be somewhere around about the 3K mark, I hope. Yeah. 1.4K. That's 1.4K. What's going on here? So going out and there. Well, it's 3K. That might make the HT a bit high, I don't know. It's never going to burn out, you're right. Okay, right, so that's the HT done, potentially. So what we're going to do is slowly wind that up on the variac while monitoring the HT. And yeah, that's the plan. Right, let's get ourselves sorted here. So that's going to be the HT there off of the rectifier through there to there, which is up here. Pardon me. So if I grab onto there, Yeah, the LT is low. We're probably going to need to do that one as well, Nick. Let's go one at a time. Yeah, I don't think we're right there because I'm up to 88 volts already. I'm only on 140 volts on the... Yeah, that ain't right. So we're going to need to put a bigger one in than that. So I've got 91 volts on the HT outlet. At 145 volts. Yeah, but I like it pretty. That's where you want a couple watts decadence box, isn't it, really? All right. And 500 ohms. So what a higher resistance, don't I? Not a lower one. I'm sure I had some. We'll get there in a minute. Hi Steve, how are you? What we're trying to do, Steve, is find a resistor for the HT supply. My little tub gone, I think I put it in deep. So I could stick a 2.2k in place of that and try. Have I still got voltage down here? Still got 63 volts down here, am I? So just using the resistor to bleed that away. 2.2k. Let's try that. Careful, Graham, you don't want to break the tag off. So let's tack this 2.2K in. I cannot see it. We're going to tacking in now, rather than permanent solder job. Oh God! Well, as if I could tack the thing in. Okay. Right. How about that? Doing. I've been copying a load of cassettes. No, the old selenium is out. I've disconnected one side of it. I'm just using this top side as a connection there. Hi Ganesh, Anthony. Let's just get you in. I'll show you what I mean. So the connection to the selenium on the bottom here is now vacant. I pulled the wire out, and this is where my diodes come off into here, and then I'm going out through this this one and back into here to the existing 1.8K. Right, okay. So let's try again. Try again. Are we ready? Let's move everything out the way. So, what am I doing wrong here? We're up to 148 volts and I'm already on 91 volts on the HT. So we're virtually the same. We haven't really changed. We haven't changed. No worries, Anthony. What am I doing wrong? I must be doing something wrong here. So Nick's saying not enough voltage on the heaters to make the valves draw current. Check to voltage offload. Is the radio on? If not, you have no load. Yeah, the radio is on. It's on maximum volume. If I turn it off, then it's obviously drops back. But I'm only on 140 volts though. I don't suspect I've got anything on the LT yet. I've got 1.1 volts on the LT. Oh, okay. Okay. I'm going up in voltage and this is dropping back. Ah, right. Does that mean it's starting to conduct? Okay. No, this is a halfway. Well, it's just a single rectifier. This one. So I've gone too far off the basics. Okay. All right, Brett. Well done, mate. Let's get this stupid thing off my head. It's making my head sweat. Ugh. Whew. So we are up to 74 volts now instead of 40 odd, but there's no FM on this one. So maybe my other resistor was okay. What do you think? Should I have stuck with the still got that rather annoying hum. Red Robbo! Hey! Thank you, mate. Just got yourself an RFM3, R25 and a 606 MB. Very nice, Rob. I think it's Rob, isn't it? Red Robbo. RFM3's great radio. The diode output will not drop off like it does from a valve rectifier. I've still got this hum though, people. I mean, do you think that could be a dodgy valve causing that hum? Ow. Paul has said about the valve seals, so I think maybe I need to go back and try the other what am I trying to say? What are you trying to say, Graham? That is. Try the other one back in and just bear with it, because it's obviously going to run higher until the valves start conducting, I suppose. Am I right? Is that safe to do? I don't know. Bugger if I know. That's the plan. I'm going to try this other one back in and just be a bit braver. I got a man up on my. It's not going to hurt me. I just don't want to damage the radio, you know. Oh, there he is. There he is. Let's just tack this on for now. I'll put it on. I'll put it back on neatly in a minute. Right. Let's have another go. Let's hook this meter up as well. Measure the LT. Right. This is a bit high, isn't it? This is better, 80. I'm not convinced I'm actually measuring in the right place there though. Let's try it on one of the actual heaters itself. Yeah, so this voltage is still too low. So whether the valves aren't conducting better, I don't know. Hi Andrew Harris, how are you? So I think this is more like it now. And maybe I can drop that, that a little bit more. I don't think I've got anything else. So yeah, it looks like we're going to need to get rid of the selenium on the LT as well. What a pain in the buttocks. Just bleed that off a minute. Where's there? To the case. Right, I think we're nearly there with the HT. What are you saying, Anthony? Keep the LT rectifier as it is? How you doing, Andrew Harris? You're in hospital? You're in hospital, Andrew? Tell us about that, mate. Hope you're all right. What's on? I'm going to crack a bit of black sheep while I'm at it, I think. Can't beat the old black sheep. Notice I'm not going for stronger ones this week. I'm trying to be good. Trying to keep my units down. Mind you, I went mental last night. That's a load of baloney, isn't it? Oh, okay. I'm with you, Anthony. Too many strokes. I'm sorry to hear that, Andrew. Hope you're on the mend, mate. You're in the right place anyway, that's for sure. Yeah, sorry to hear that, Andrew. Johnny! How you doing, Johnny? Good to see you, mate. Did you sort out that battery issue with that Upatero? Did you sort out the issue of the batteries? Well, I think it's a battery issue. See, that voltage is just creeping up again a little bit, isn't it? It's weird how it does that. Right, we need to find a bridge rectifier. 2 amp, 800 volts. I think this is the low ones. I think this is the ones that Simon said to get. Just need to check the spec on these a minute. I think these are lower voltage bridge rectifiers. Let me just Google this part number. Still playing up, Johnny? Oh no. Right, let me just Google this part number, see what these bridge rectifiers are. So it's a KBP. KBP 2005G. KBP 2005G, 2 amp bridge rectifier. So I've got these. I've only got 2 in stock. I could sell them some more. Look. We're not going to have any until June. Yeah, June. So yeah, this is what I've got, and they are 35 volt maximum RMS input, 60 amp peak surge overload rating. Well, that should be fine, shouldn't it, for my bridge rectifier on the LT side. So this is a 2500G, it's this one here. Input voltage 35 volts. Well, we're less than that, aren't we? That's maximum. Are you off? Another bottle of Jack Daniels? Christ, Sean, go steady. Got mind of its own. Yeah, the battery contacts were a real pain in that one, Johnny. They were so badly corroded, I had to botch it all together to get them to work. I can't remember, I did a lot of work on that one, but I just can't, off the top of my head, remember exactly what. So that's what we're going with. Okay, where's my drawer with my bridge rectifiers in now? Can't see it. Oh, there we are. Okay. So I'm probably going to need a tag strip for this. We got there, got a massive bolt holding that in. So that's our AC coming in off the transformer, I believe. Right, let me just get cleared up here a minute. Let's get these out of the way. What car? Yeah, well, you dog walking? You going dog walking? Taking the doggies out for a walk. Okay, that's positive there. Just trying to see if I can utilise this again as a... So that's ground. So that's the negative there. I could use that as a ground still. That's my AC and that's my DC there. Right. Can't quite see where I am, can you? Let me just get you up. So there's our selenium on the LT circuit. So that's ground. And that's our positive. So there's only one wire because the actual chassis of this is grounding it through this nut and bolt here. Let me have a think about this then. So if I do that there, just double check that that is definitely ground. Ow. I'm sure it is. It's not a great ground, to be honest. Yeah, no. No, that's not a great ground. I'm not going to use that. That's not ground there, is it? Ah, okay, hang on. I might have got myself mixed up here. What's going on with this one then? Well, this one here is closer to ground potential than the actual... I'm not sure on that. Hell. So I'm just going to have to wave this around in thin air to start with. I don't trust this. You don't trust this. So that is our windings off of our transformer. That is ground, but I don't think the transformer windings will stretch over there, will they? Look at her. That one will. That one won't. Okay. think, Graham, what we try to do here. Do that as the positive there. Link that one onto there. Yeah, okay, could do it that way. Bit of a botch this, but let's see how we go on. Bit of a botch. Resonator, how are you? It's 1.5 on this resonator. Been discussing doing the valve tester as well, resonator. That's going to happen soon. Going to get my mate Les there on the situation. Okay. The long-awaited valve tester. Just double check. You may be right, Mr. Resonator. I assumed it was 1.5 volts. Pardon me. Yeah, it is 1.5 volts. It's 1.5 volts on the LT and 90 volts on the HT. It actually uses a B107, which I thought I had here, but I haven't. Yeah, so you made me doubt myself there, Mr. Resonator. Keith, how you doing? Fat Tony, how you doing, mate? You think a new LT rectifier would get rid of the hum? Okay. Yeah, that fits on there, so let's make sure we got enough there. It doesn't want to go on this wire, does it? There we are. So let's poke that back in there. No, maybe not. Maybe it's going to have to come that way. Let's get myself sorted here. I'm in a bit of a mess. Been busy with a 4-acre field. I can change a module quicker. I can. Right, so what I'm going to do is I'm just going to tack these on and slide the heat shrink up to protect them. I won't heat shrink it up yet, just in case it's a complete and utter lash up. Let's say this is only temporary at the moment. I don't know what this is going to do to our LT voltage. So, is that long enough to stretch over to there? I don't think it is. It might be. Will you go over there? Yes. Oh, look at that. Stretchy. Dear, dear. Right, so this is the positive. So if I pull that around, stick it in the hole. What do you think then? So I'm only using the terminal on that just to hold the positive side of this, and I will probably stick that through that hole in a minute. But, so that's negative onto there. Positive coming into this strip with our little stringy thing, and this are windings off the transformer coming into the middle, which is AC. There we are. What do you think? Absolutely amazing, or what a rough job? Probably need to add a drop-in resistor. Should you use an RCD with your lamp limiter? I don't think it would hurt, Brett. I mean, my Variac's got an RCD built into it. My isolation transformer come Variac, and I plug into that, so okay. Let's hook back up again then. All tangled up with everything here at the moment. Actually, let's check it out, the actual valve base itself. That's our true LT reading, isn't it? HT. So I'm aware that we probably are going to need, let me think, where was I checking HT last time? It was up here on this cap, wasn't it? That one. Was it that one? I think it was. Right, full volume, speaker leads connected, let's get that out of the way. Too much stuff on the bench. Right, here we go then. Ives, how are you? What brand is yellow and blue ones? Do you mean the meters, Ives? Not actually focused on them, is it? That's better. Hey, well done, Andrew. That's good news, mate. Great stuff. Good stuff, Andrew. Right. Okay, why are we showing a minus figure there? Because I've got my leads on backwards. Yeah, great, Graham. What the? Okay, let's just sort that out. Let's do my head in that is. Right, okay. So it's going to need a drop-in resistor for sure, Rob. I'm keeping a close eye on this then. Well, I'm wondering if I'm measuring it in the wrong place here, because I'm up to 240 volts.
Very shortly. For dedications and shout outs, you can get hold of us on our contact at BBC7 now. Go give us a like and a follow. Text 81333, starting your message with the word Devon. Coming up, if you are someone or you know someone in your family who has experienced really awful pregnancy sickness, it's an exciting new study.
Yeah. Yeah, that was measuring 2.2 on the positive of that rectifier. I'm not sure whether I'm measuring it in the right place, but I'm sure that that pin is the heater. Let's have a look. This is where it comes up, I believe. It's 1.5 at the capacitor there. Let me get my let me get the manual back up again. Whew, it's getting hot in here again now. Okay, so we've got L17, which is the choke, haven't we? Coming up, that's the choke. Head scratching time this is. So if I measure the output of the bridge there, that's where I'm getting quite high voltage. But I need to be measuring it at this point really, this S16, which comes off of the junction of C25 Okay, let's just pop the power off a minute. Just bleed that away. So that's my positive. We're coming in, we're going through L17. the other side of L17, so maybe I'm measuring the wrong capacitor. So let's have a look here. So that's that one, that's coming up. Yeah, that's that one, that's coming up from there. Okay, so I'm measuring it at the wrong place. I need to measure it up here then. It needs to be on that capacitor there, which is the junction, and it goes out to the switch, I believe. Let's have a look. Yeah, that's the other one. So that's where I need to be measuring the LT from. So I need to be measuring the LT here at this junction, really, after this choke. I need to be measuring the voltage there. That just goes through my switch and then it goes out to the LT circuit. So that's that is what needs to be our 1.5. So now I'm the right way round. I might have a chance of getting this right.
But obviously that's not sort of okay at all in this day and age. So it really is horrific. It's all day, every day, for months and months and months, and it affects every aspect of your life, not just eating and drinking. Very distressing and frustrating, as you say, extreme dehydration can require hospital treatment. What kind of treatment did you receive? Yeah, I went to hospital with each of the dehydration treatment, but I also had to take medication, with regular morning sickness or pregnancy sickness, which is prefer it to be called.
So 1.25 on our...
It's quite a last resort, really, to be having to do that. But there are lots of post-treatment treatments available, and
LT.
to take them when you're between that rock and the
But we've
hard
dropped
place,
down to 77 volts now.
It's a horrible decision for any type of person has to make. But yeah, I had medications in each of my pregnancies. I wouldn't have been able to survive them without them. It was as simple as that. I wouldn't have survived. So very distressing and frustrating time for you, and you've been inspired now to help out with this study. So I've gone into a research route through the charity through my own work as well.
This is really confusing me now. What is going on?
To conduct this study and help to recruit pregnant women to it, particularly the first trimester is difficult because women don't realise, don't like tell anyone they're pregnant and aren't necessarily looking online and so on. And so we're trying to recruit women. We have a helpline so women contact us for information and for support, and then we can direct them towards this study. But we don't get support from women who don't have very extreme pregnancy sickness, so recruiting control is more difficult for us as well. But our women just really want this kind of research to get out there. People don't believe how much they're to take this take. Hopefully this study might really help some women out there. Yeah, that's what we're really hoping. I mean, I met Caitlin a couple of years ago and I was really shocked. I'm a dietitian by background and I was really shocked that actually...
Yeah, so I got 1.26. I had 1.1 something before, didn't I, with the old rectifier in.
We know anecdotally that women with this condition are eating very little, but we need to have that in research and evidence. be able to find out what the effects are on the pregnant husband itself and on the baby, because you may know that there are potentially quite severe effects for the baby, so because there might be born slow,
Wow.
born preterm, and potentially some longer term effects.
But the hum is a lot better. There's still a bit of hum there, but can you hear that? That's a lot lower. Let's just over voltage it a bit.
Yeah, so I mean, there's lots of stigma about this, and lots of stigma and misconception that's been disproved, but there is a genetic link. So one of the things that is known as a suspicious component that is also associated with cancer and with the cachexia, so the real sickness and loss of appetite that occurs with cancer. So there is a,
So I'll tell you what we'll do, being that we're fairly safe at the moment, I'm going to plug this directly into the mains. And we'll test it. There is an RCD on this, and I'm going to keep my hands totally away from it now.
myths that have been mentioned in the past about it being psychological in nature are completely disproven. So you do need people to sign up and help with this study into
Yeah, so that hum has cut down considerably, but we've only got 77 volts on our HT. Yeah, I don't know why that could be, Rob. It might just be that particular rectifier is doing something, or it could be that maybe there's something internally in that old rectifier that's grounding it a little bit. That's a point, because I've used it as a tag strip, haven't I? I wonder if that's got a bit of leakage to ground, if you know what I mean. Yeah, let me just show you what I mean. If we can find my let's just bleed off that voltage. There we go. So yeah, what I'm saying is I am connected here. I've used the old selenium as just a tag to tag onto. So I mean, if that was, I don't know, maybe slightly grounded through the body of this, that might drag it down a bit. So it might be worth just lifting that and joining those together to see whether that would make any difference. I don't know. I'm open to ideas. You think? Yeah, see, Anthony, that's what I'm thinking. Let me experiment with that a minute then. So it's all disconnected and I've bled the voltage off of it. Come on. So let's just pop that away from there. Connect that on there with a blob of solder and we'll try it again. Okay, there. So now I'm disconnected from the selenium altogether. Ah, dear, oh dear. It's fun and games, isn't it, eh? We're getting there, though. Like British Rail. And all sorts of stuff about the railways in the news. I've sort of turned a bit of a blind eye to it because The railways used to be really good back when all the lines were open, but when they absolutely crucified it and closed all the lines, it's really made it pretty useless for local travel, isn't it? Okay, right, let's try this again then. Let's try it again. We'll go with the variac again this time. Make sure I'm all connected up. I'm connected to the right places. Yes, yes. Here goes then. Still the same. Yeah, well, that really hasn't made any difference, has it really? Yeah, that's what I've done, Steve. It's there's no connection to the rectifier whatsoever now. Uh, 1.3 volts on the LT. I wonder, maybe my capacitors are loading it down a bit, being that I've gone higher in capacitance. I've got 2,700 microfarads now. 2,700 microfarads. But clearly this is still too low, isn't it? You might have the capacitor problems as acting like antennas because of the foil side. You think it's from a bad earth connection, Rob, do you? Could be. It could be. It could be. I mean, end of the day, we've only done the caps. I mean, there's dozens of resistors in this thing, so any of those resistors could have gone bad. I mean, that is too low, though, isn't it? That needs to be 90 volts, really, or up near there. Do not increase power electrolytics values. I've gone from 2,500, Steve, to 2,700. I can go down lower, I can go to 2,200, but I haven't got a 2,500. So do you think that could be it? Tony, Thank you, mate. Hope you're doing all right, Tony. Stick to normal 80 microfarad values? Hey? They're 2,500 microfarads, the original ones. So the HTs were 40s. I think I could put 47 in there. And the LT ones were these, which were 2,500s at 3 volts working. It's only a question. I mean, I'm clutching at straws, really. Hello, that's my phone. I'm just checking, make sure I'm not reduce them, Steve is saying. Mr. Colson does know. I mean, we did discuss this. I think it was Theo that said to me that sounds way too high for caps. I mean, it could be this thing that one of the caps is the wrong way round. One of the foils isn't the correct. I don't know. I mean, this voltage, this is too low, surely. Yeah, if you want to have a quick look at the schematic again, Steve, let's pop that up on screen for you, look. So there's our two filter caps. McAfee's speeding up my app, apparently. So this is our two filter caps. They're 2,500 microfarad, look. And I've put 2,700 microfarad in there. I could go lower. I could put 2,200 in. But usually the older caps were minus 10 plus 50%. So I think we should be fine with what I put in. God, all these lemon things popping up. So say I'm measuring the voltage at the other side of L17 here after the bridge. I mean, if I measure the voltage before L17, if I measure the voltage before L17, which is obviously directly off of there, so if I measure that, so the voltage directly off of the bridge is 2.35 volts, look. Then it comes down through this funny squiggly bit of wire to here, which drops it again to 2.25. Then it goes through that choke and it comes out up here at this capacitor, which is our 1.28. I mean, to be fair, that's listenable at the moment, but I need to mess with that. Spot check some of the resistors in the HT. Looks a bit squiffed. What are you on about, Sean? And welcome back, mate.
A travel agent in Strasbourg, Luke Melly, said the service on
Good call there, Rob. So what is a V4? V4 is up here, isn't it? So this is the DL94. Let's substitute the DL94 then. Let's see if I've got another DL94 a minute. Let's swap DL94 if I've got one. I've got a little bag of valves for these. Just having a look through here. Definitely ain't that one. Oh no, hang on. These are for the DAC 90A, so it's not going to be in there, is it, Graham? You fool. You fool, man. No, it's not going to be in there. I thought I ordered one of those in, you know. What's that there? No, it's not that one. Bear with me, I'm just I've got a big stash of valves here in the bedroom that I've not gone through yet. That's in the bedroom. We always keep your valves in the bedroom, don't we? That's the correct place for them. Yeah, no, I've got DK. Yes. I've got a valve in there, but I think that's a spare rectifier valve. UCH 42. So you wanted that for something. Okay, it's time to probably rob another one. I've got a little container with a few valves in here. Let's have a look at these. I've got a few little valves here for these radios. So we want a DL94, DF96, 96DK. I've got DK96s. DF96. Everything but. Okay, so I'm going to have to go and pinch one out of another radio. No guarantee that that'll be any good though. Let me go and have a look a minute. Talk amongst yourselves. I'm going to have a quick comfort break as well at the same time. Right, let's go hunting for Another valve portable. I wonder if that one will have one in it. Roberts. Again, there's no saying that this is going to be any good. Is that D4? DO96, that is. Different output then. Is that compatible, DO96? Let's have a look at the Roberts Junior. That might have a DO94 in it. Yeah, so one of the slightly more modern Roberts has got a DO96, not a DO94. Just got the Junior here now. Michael, how are you? A valve data and equivalence book. Let's have a look at this one then. Which is the output valve? It's got to be. Must be that one, surely. A DO92. Yeah, see, this is an older radio again. It doesn't look like I've got one that I can pinch. Let's say I've got a DO96 in a Roberts R66, I think it is, or 55. I'm not sure. Bill's here, is he? Where's our battery maker? Is he? Where's Uncle Bill? Bill? I can't see Bill. The radio states 2,500, Theo. That's what was in there. It may help if you check the rectifier output voltage with all the valves removed, then place each valve back, checking the output from the rectifier each time. Okay, we can do that. You let me borrow your valve tester, Steve? You need a valve data. Rich, how you doing, mate? Try new valves. Increasing caps causes the ripple current to go up. Can take them past the RIP current. Try new valves. Increasing caps causes a ripple current to go up and can take them past the maximum ripple current. Oh, those values are for a silicon rectifier. Okay. So we're thinking try try changing the caps that I put in on the LT circuit, these two. These are 2,700 microfarads. I certainly haven't got any 2,500 microfarads, that's for sure. Unless, what are these old ones here? $1,500, $3,300. Yeah, I mean, I've got some 2,200s, 35 volts I can chuck in there, 105 degrees. Any jack-ons, but I don't know, we're sort of going round in circles here. I'm really not sure what to do next here at the moment. It's got lots of different suggestions coming in. Unfortunately, I haven't got a replacement valve unless that... let me just quickly look up... Oh, hang on, wrong one. Look up the Valve Museum a minute. Oh, you're saying the LT caps are fine, Rob? I mean, they are, I did put them in rather neatly. They are quite nice. So back to basics, check output from the transformer to each rectifier, is it as specified? From the transformer to each rectifier, is it as specified? Okay, Theo, let's have a look. Oh, I did say I'd need some help with this, didn't I? So there is no no voltages shown for the transformer. Oh, okay, this is useful. Richard has, with these schematics, he's got some valve equivalents there. Look. So he's saying a 3V4 and N19, a CV1633 or a CV2983. Yeah. So I mean that's favourite is the output valve, I suppose, isn't it? But surely we need to get the HT up as well, or do we think that could be being pulled down by? I think that was what was said, wasn't it? Being pulled down. That's there, isn't it? I mean, we can run it without an output valve, can't we, and check that? I mean, I haven't got the output. Oh, I can pull the output valve and try it. Actually, I need to probably pull that back a bit then, just in case. So now we've got a higher heater voltage alert with the output valve out as well. We've got 1.57 on them now, which is a bit high really. And I'm not going up to 240 volts yet. And we're getting higher HT as well. I mean, I don't know. I'm clutching at straws again, people. I'm clutching at straws again. Let's say I'm at 220 volts at the moment. I mean, obviously, I assume that the output valve is the one that draws the most current. Let me just wind that back a bit. I mean, that would be perfect there, wouldn't it? Are the valve heaters in series? No, they're not. They're parallel, I believe, on this. Yeah, that the valve heaters are in parallel. Just turn it off for a minute. I'm just going to quickly check my valve list, see if I've got anything that is listed in that. Get off. Yeah, I thought I had some spares for these little battery valves, but I haven't, because I've used them in sets, but I haven't got that one for sure. Alright, let's have a look then. No, I don't think I've got any of these. DF, DK, no CVs, no 3V4, no N19, that rings a bell. Just going to go and get my box of valves a minute that I haven't sorted. You never know, there might be something in there. I don't think so, but you never know. None of these are battery valves. These are all mains valves. Fs, DKs. No, I haven't got nothing. Nothing. I've got lots of mains valves, but no other battery ones. Just what this little suitcase radio is. I think I've popped that up in the loft. Actually, we've got this one here. Let's just check this. This is my next valve radio project. I did have a look at this one at once upon a time, but we've never done any work on it. Bit of a dodgy arm at the moment. I don't know what's going on with me at the moment. Falling apart here. Right. This is going to be my next next valve radio project. Another Roberts, look. Pardon me. So let's see what this has got in it. Oh, look at that, a DL94. Thank you very much. And this is the Roberts CR, but we do have a DL94, so we can give it a try. Oh, that's a bonus. Thank you, Mr. Roberts. Okay. Oh, excitement. Oh, we're there. Miles out now. Whee. Right. So that's the DL94 out of that one. This is a DL94 out of the other set. So that's, I mean, there's no guarantee that this is going to be any good. Is the output valves that get hammered, isn't it? Let's check this again. Let's hook it all back up with a different output valve in it. This is why I need that valve tester, Mr. Resonator. I've got to get it going. I've got to get it going. I got to get it going. I mean, Les will have to have a look at that. We're in the middle of a Russian radio at the moment, trying to sort that one out. It's been a pain in the neck. Right, fire in the hole. So I've turned the voltage down on the variac. Come up a fraction, look, 79. I think it was 77 before, so it's come up a couple volts, but the heater voltage is the same. I don't think we've gained a lot in volume. Paul was saying about the pins in this one. Wow. I don't know what else to suggest. We substituted that valve. Okay, Rich is saying to leave the output valve in and remove the others. That way you can tell if the hum goes. But there isn't... Yeah, there is a hum there. So that's V1, 2, 3. Okay, here goes then. Whoa, 1.96 on the heaters now. Let's get that down. Yeah, heater voltage shot up then. Yeah, that heater voltage went right up then, because I don't suppose there's any load on it, is there? If output's correct, disconnect the rectifier outputs and set the outputs to what the spec sheet says by selecting the correct dropper resistor. Okay. As I say, unfortunately, I can't wind it up because this LT voltage is going too high. I do have a signal tracer, Anthony, yeah. Let's pop another volve in then and see what happens. V3. Let's pop the power off a minute. So we've got a humbuck with V3 in there. So we've got a humbuck with V3. What's V3 then? It is an IS5 at the moment. What should it be? DAF 91 it should be, when IS5 obviously is okay. DAF 91. Let's go Robin again. It's V3 on this one. DAF 91. Poor old Mr. CR, he's being robbed blind here. Let's try that one. That's quieter. Or maybe not. Let's just try that other one back in again for comparison. Put the shield back on. No, they're about the same, I think. So what's the DF91? Let's try the DF91 from this set, if it's got the same valves. I suspect it has. DF91. It's got to 240. So HT's come up with that one in. Sorry, the LT's come up. But I'm still one valve short, aren't I? Let's put the last one in from the other radio. So now we've got two of the valves from the other radio. Well, it's pretty loud now. Let's put the oh.
Third place, leading 2-0 against Palace. There will be a decent teammate of Sergio Aguero as well. Another goal at Ellen Road. Oliver Butler.
Delhi 3, West Brom 0, and are you watching Gareth Southgate? Patrick Bamford from the penalty spot right down the middle in 17.
Liverpool lead 2-0. They look like they're Chelsea and Leicester City, 4th and 5th. Chelsea have the advantage only on goal difference. Leicester City 2, Tottenham 2. West Ham for the Europa League in 6th.
DF91.
There's still plenty of fighting heart in the Chelsea team. They still believe that they can get something out of this game.
So now we're going to go with all its original valves.
And Jacob Ramsey coming on. Let's get back to Leicester City. Alistair Bruce ball. Corner for Tottenham. Danger for Leicester at the moment. They're chasing that third.
Is it let's try that one again. A DK92. Oh damn, rubbed the numbers off of that one. There's a DK92 there. Let me just write that on it. suspension's very fragile on these.
But in terms of slender advantages, Chelsea certainly hold that against Leicester City with 10 minutes remaining of normal time here. And they're trailing by 2-1.
Well, not a lot of difference to be honest. Not a lot of difference. With a different set of valves in it. I think that is the original output, isn't it? Yeah. What's the verdict then? We probably still need to do something to the HT to bring it up. Derek, thank you very much, mate. Surely, do we not need to sort that that HT out? I mean, if I just pop it back on again.
3-minute run out, and here he is, probably lasting the full 90 ahead of Gareth Southgate's England squad.
I mean, we're 10 volts down on this.
Behind it goes for a corner kick, and Chelsea are still looking to try and get on level terms. There's Stuart Atwell.
Let's just try it directly in the mains.
Delaying a restart, and it comes now from Reece James, corner kick. Referee wasn't happy.
So I take my aerial away.
With supporters being inside the stadium, we had to arrive earlier than normal. Feels like we've been on a holiday here at Villa Park today. We arrived that early. In comes the corner kick this time. Only as far on the edge of the area. Pulisic leaves it for Mount. Mount forward. Blocked by McGinn. Is the counter-attack on? No one back by...
Cycling challenge throughout May. Carly and Ronnie have been catching...
And it could change. There's another goal at Leicester. That has been... But it's at West Ham.
The party has begun. West Ham 3, Southampton 0. Declan Rice cut in from left-hand side, rolled it in. Second of the season, West Ham 3, Southampton 0.
As Piliqueta with the cross, they really are laying siege down to Aston Villa.
Yes.
Another corner. I just don't know whether you should try something different here. Try and pull somebody out of the pipe.
The hum hasn't gone really. The hum is still there. The hum is still there, but it's. I think the rectifier. I mean, I've got a weak station there, but I'm just looking at the IFs, and they're all. They're all wax filled, which is a real pain. How are we doing for time? Let's have a look at the time. What are we doing? 6:15. Have we got time to have a go at the IF alignment on it? See if we can pull that up, or do we need to mess with that? Do we need to mess with that filter, that dropper resistor still or not? Let's get some bits off of the bench here. Then we can have a look at the alignment. Might be able to do it by ear. Cheating a bit, but you know, when you've done quite a few, it's you just find a weak station and trim the IFs for stronger signal. I don't think it's going to matter on this about shapes of the wave and all that sort of stuff. Floppy! That was you humming, was it, Floppy? Cap or resistor gone noisy. We've changed all the caps are gone, unless it's one of the no, there is no caps unless it's one of the disc caps in it. I've got to remember I'm plugged into the mains now, so let's just unplug that. Get rid of that. Let me sort my bench out a minute because I've got a lot of leads out. It does seem that the output valve or circuit is pulling the voltages down, but I have substituted the output valve, but it doesn't mean to say that the one I've substituted it for is any good, Theo, really, does it? So I'm not really that well up on these types of radios. In theory, it should be easier to work on than a transistor radio, so everyone keeps telling me, but it's what you're used to, isn't it? Just sort myself out here a minute. Untangling everything. Yeah, I think you're right, Doug. $2.7K. I think we've got 3K in there at the moment, haven't we? In total, because that one's slightly under. Let's just bleed off any HT that's left in there. And let's look at the instructions to see what I'll get the cameras right in a minute. Paddy, how you doing? You've been watching quietly, Floppy, have you? Bishop's finger will take the hum out. Yeah, probably would. Order some whiskey to stick in your tea. He could do. Good idea, Harvey. Okay, let's have a look then. Let's have a look. It's never going to be great with a frame aerial anyway, is it, people? We'll get it a little bit better, I think, but I don't think we're going to see a massive improvement. Just seeing if there is any alignment info on it. Circuit description, IF, okay. Yeah, I don't think there's any alignment info on it. Unless I'm cracking up. Valve analysis. General notes. Export models. Oh, that's a bit bizarre. There's no no alignment info on it. Unusual. I can probably work it out. Can't be that difficult, can it? 472 megahertz. Kilohertz. Unusual. No alignment info for it. Theo saying if a valve heater goes open circuit, then the remaining supply should not go high enough to stress the other heaters. But it does when the output valve is pulled. So what you think, you still think the output valve is pulling it down, Theo, do you? I'll have to order up a new old stock, I suppose, DO94, or try and get this valve tester working. Yeah, I'm just trying to find the other files that on the RMB. RMB alignment. Here we go. So I've got to put a 0.05. Here we go. Pin 6 of the V1. Pin 6 of V1. There's V1. Oh, you're supposed to get in there. Jesus. Which way round do you count this? See, this confuses the hell out of me. Which way round the valve bases go? So do they go clockwise or anti-clockwise looking at them? I don't know enough about them. Control grid of V1 pin 6. So we also had this, we had 21 volts on V3, didn't we? We had an incorrect voltage on V3. I think it might be beneficial to try and measure these. I mean, milliamps, I'd have to disconnect wiring to test that, wouldn't I? I can't test that in with it all connected up. Screen volts. Screen milliamp, oscillator volts. Oscillator milliamps. But saying that, I have tried other valves in there, haven't I? So it could be that something's messing with the anode of V3. Where's my other schematic? Go back up to the top here. V1, V2, V3. So we've changed those caps. We've got a 500k resistor there that could be cocking it up. R9. See if we can find R9. Has it got a picture of the back of it? Or we're going to have to go hunting for it. Where's R9 then? Seems that there's not everything on this. Bear with me, I'm going to have a look, see if I can find the layout of this. RMB schematic, alignment. Yeah. It's a head scratcher. That's the alignment, we've already got that open. Notes 1. No, I want the a diagram of the back of it, really. I don't think there is. Ah, here we go. Here we go. This is a page I got missing. It's difficult, isn't it? So R9 is on the back here. So looking at it that way. It's the fourth one in. 1, 2, 3, 4. I was going to check that a minute. R9 is, I mean, it'd be worth checking all of these, really, wouldn't it? Because I doubt very much whether they're anywhere near what they should be. Let's see if we can get you in. Right, so according to this, R9 should be I think I said 500 ohms, didn't I? Let me just zoom in a bit here. This is the anode load, 560k. 560k, so one, two, this one here. $534. Is that enough to let that extra voltage through? Come on. $534k. What else have we got there? We've got R8, which is 4.7 mega ohms. R8 is 1, 2, 3, 4 components up from the bottom. 2, 3, 4. That's this one here. .2 mega ohms. What did I say it should be? 4.7 mega ohms. So it's just null this meter out a minute. That's not gonna make any difference at that resistance, is it? 4.2, it should be 4.7. R12 and R13, let's do those. R12 is 390. $360, so that's down. And R13 should be 2.2 meg. 1.8 meg, so that one's down as well. How they're all low. I mean, we've got a dodgy looking cap there as well. 0.005. What's the next resistor? I think that's the one that's supposed to be 560k. It's 530. It looks like we're going to have to go through all these resistors as well. What a pain. It's very strange though that I've not had to add a dropper resistor in on this bridge rectifier though, isn't it? I do find that a little bit strange. Oh well, I think we've gone as far as we can today with this. I've got no valves that I can try in it, other than the ones that I have tried out of the CR. But again, we don't know that that's working. What's your thoughts, people? As I say, I've just tried a few resistors there, and they're all low, which is unusual. I always thought resistors went high, but these seem to have gone low, which is a bit of a head scratcher for me. What model RMB is this radio? There's only one RMB, Theo. It's clockwise on the bottom, from the bottom clockwise. You're out working in the heavy rain. Is this an RP4 or an RP5? It's an RMB. It's It's just an RMB, Theo. Yeah, so if you look at that, it's the RP4 is the battery-only version, and the RMB is the AC mains or battery. You're thinking about a different model, Theo. They're all close enough, valve sets are not that critical. So I'm looking for one that's way out, aren't I, really, Doug? %20 tolerance, yeah. Yes, I'm going to have to go through them all and check them. There's loads of them. I mean, this one, you know, our HT's not quite right yet. I need to sort out this rectifier down here. I need to sort that out. I think I can probably stretch that across to here, actually. Which is where this wire comes from, and do away with this wire. Or put a rigid wire or something in there just to firm that up a bit. I don't like that floating about like it is. Or I've got to take the selenium completely out and just put a tag strip on that, maybe. I don't know. It's certainly an interesting radio, though, isn't it? Are there any other resistors not on that board? Yeah, we've got a bank down here as well. Resonator. There's 2 in here. I mean, it's quite good that they've put them, actually, most of them, on these tag strips. There is one stuck up underneath here. That's across pins 1 and 6. So there's a resistor across pins 1 and 6. Let's have a quick look at what that is. I've lost me thing again. Pins 1 and 6. Well, 1 is the heater. And 6 is one of the grids. Is that R7? I'm not sure. Let's just have a quick look at that one, because that's interesting that that's right in on V3 where we got that. Well, we did have that higher voltage issue. Can you see where I am there? V3 is in here. I don't think you can quite. Yeah, you can just see it there. Look, peaking. It's peaking. It is yellow, purple, green, is that? Yellow, purple, green. I think that's 4.7 mega ohms. Yellow, purple, green. Let's look at R7. Yeah, 4.7 mega ohms. That's the V3CG, which is control grid, is that? 4.7 mega ohms. So if I pull that valve, I'll just be measuring it direct. It's 3.8 mega ohms, should be 4.7. That's a fair way out, isn't it? Or isn't it? I don't know. I don't even think I've got any resistors that big. Just trying to get a decent connection on it. What's going on there? Oh, my meter's playing up. Can't get a decent reading on it though. Yeah, 3.8 mega ohms. It should be 4.7. I'd say I don't think I've got any resistors that high. So 6.8 mega ohms, 15 mega ohms. No, I haven't got any of those. Oh well, it was worth a look. But that one is a bit lower than it should be. 4.7 megs, it's measuring 3.8. Yeah, see, we've got some of these sort of like dog bone capacitors on here as well. I don't know how reliable they are. I mean, some of them have got a weird sort of film on them. I don't know if you can see. Let me just get you in there. So this is the sort of tag strip with all the resistors and capacitors on. But can you see, like that one's got this white powder on it, and this one, and that one. You know, almost like it's overheated or something. I don't know what it is. And this one's, excuse me, this one's looking a bit flaky. A ceramic disc one, 0.05. But I always thought these were quite reliable. I don't know if these are mica or not. I'm not sure. And say the other ones again have got a similar sort of weird thing going on down the bottom there. If you look at those, we've also got that white on there as well. So I don't know. I mean, my work's nice and neat, isn't it? You can't find a circuit diagram for the RMB radio. It's got a trader sheet, Theo. I'm sure Radio Museum have got it. If you drop me a message, I'll send you a trader sheet across, Theo. I don't know if I can share it from here or not. Anyway, that's pretty much it for today. There's not a lot more I can do. I could start aligning it, but I think we need to check the voltages first, make sure that that's all okay. Keith, 20% torque, battery set to boot needs alignment. It does, Keith. Are there any other? Yeah, I think we covered that. Just checking back, see what I've missed. Where's Mr. Man Cave? Is he back? Is he back with his stash? He's back with decisions, he says. You want to look at the output valve circuit. Okay, Thea, let's get you in on the output valve circuit in a minute. Then I will shoot. So there we go. Just come back a little bit. So here's the output valve, Theo. V4. So we've changed C22. That's done. C20's done. We've got R11 here, we've got R13. I suppose either of those may cause problems on the output. I don't understand this heater setup. It looks like it's in parallel or something, doesn't it? I'm really not sure how that works. Was it got two heaters in it? I don't know. Can you see that, Theo? It's a bit better. Let's move that over there. Get off. Get all the caps renewed anyway. He's with Jack Daniels. He's having a Jack Daniels party resonator, is he? So, I mean, I thought those little sort of cylindrical caps were okay. I thought it was just the waxies that were an issue, but I couldn't check the others. This heater's wired in parallel. Yes, so that's our positive LT coming up there, and the negatives tapped off the center of it. So I say, certainly when I removed that one, the heater voltage shot up, didn't it? Has that sorted you, Theo? As I say, I've done pretty much most of the capacitors, apart from those red dog bone type ones. I can lift them and test them in circuit, just to see what they're doing. It looks like we're going to need to do another live stream on this. Take it a bit further. We've done both the rectifiers now. We've achieved that today, if nothing else. Yeah, we've achieved that today, if nothing else. So we have made progress. We have made progress. That's it today, people. Hope you've enjoyed that. It's one of those things. I'm no expert on valve stuff, and it's good to get out of your comfort zone sometimes, isn't it? And I learn stuff every time I do it. So one day I'll know what I'm actually doing. It'd be amazing, wouldn't it? Hopefully you've all enjoyed that today anyway. It's a bit different. Say we can continue it, you know, to be continued for sure. Either on Wednesday or next Sunday. One of the two. I should be on this, pardon me, this Wednesday. Nothing planned, so all is good. Tony, thank you, mate. Hope you're well. So yeah, thanks again to everybody that's contributed today as well. I don't think YouTube will let me see who it was. No, it's yeah. I can't tell who's I've only got the last two, which was Derek and Tony, but I know Sean did and Rob did, and there's quite a few people that put super chats in. So yeah, Tony, Rob, Red Robbo's Workshop, and I believe he's got a YouTube channel, Mr. Red Robbo. You can't go to people's channels now, though, can you? On here, which was quite a nice little feature. So we'll have to check out Red Robbo's Workshop if he's got one. So thanks very much, Red Robbo. Very kind donation. And it won't let me go back any further than that. It's strange what this chat does, doesn't it? Arena Engineering, hello mate. You've been lurking in the background. Good to see me going at valve stuff. I need to get my valve tester done. See, if I had that valve tester up and running, Resonate, I could just pop that in the valve tester, test it. No problems with that valve, but I can't. I need to get it done. I need to get it done. I was studying the schematics the other day with Les, and just got to get this whole phase thing right and work out how the hell it's all wired up with all the new wiring that's been cut off. So valves stir the history. I do really like this radio. I would love to restore this properly, but I've got to get it working properly power wise. I've got to get it working properly. So all right, Theo, as I say, I can pop you across the schematic if you haven't got it, mate. So that's it for now, people. Thanks everybody for joining today, and I hope you've enjoyed that. And are you going to do a live stream when you calibrate the valve tester? That would be scary. I'm not going to do a live stream when I put the transformer in, because really I cannot concentrate on the chat and everything and try and do that transformer. It's an absolute nightmare. So we'll sort something out. The resonator definitely going to be shown. And the calibration of it, I haven't got. I think you've got to have a special sort of reference valve or something, haven't you, to calibrate it properly. So I don't think. I don't know. I don't know is the answer, resonator. But you'll have to fill me in on the info on it. And we might have a go at calibrating it. I thought you said you had calibrated it actually, but it's obviously different voltages over here. So that's it, people. Bye for now. And say, don't forget, if you're not subscribed, hit that subscribe button and click the bell, and you'll know when I'm on next. Bye for now.